of these features. So another important thing is these programming language is kind of open source. The tendency of open source and the community supporting the background, it actually makes more sense and doing developments and deployments in Python. So to go for more with other information, so basically this whatever the programs written in the Python basically converted into a machine level code during runtime by an interpreter, rather than compiled into a exe or a executable before running into that deployment. So basically this way it is actually kind of differing from the LabVIEW. So another kind of slight differences is actually the prototyping part is something made more easier for the beginners and the users to leverage the existing use cases of Python. Basically, like say for an example, variable declaration in Python is so much fun. Basically, you haven't worry need you can declare any kind of variables in Python without being declared into a particular data, which is kind of easy things to learn at the start. But if you are an experienced programmer with the same kind of attitude, which may run into some typecasting errors. So some other part is like it actually giving some easy portability between different systems. So that is an important aspects we're going to discuss on today's uh, presentation. So yeah, so let me compare the use cases and the best cases with LabVIEW and Python. So let's say for an user interface, LabVIEW has a built-in front panel which is coming up with various different icons and required functional element, not functional elements, like visual display elements, which can able to represent different graphical and numerical and some user interface concepts. So that actually comes up with LabVIEW. So with the help of the built-in controls and indicators, you can be able to make a easy play around LabVIEW. And also there will be like an external libraries which supports the user interface development. Whereas in Python, you have to Python is something like it is actually you have to set up a system. LabVIEW is kind of ready-madely available laptops for something, where Python is something like you have to set up a complete system with, you have to choose your processor, you have to choose your all the specs like. So where you have to basically once you install the Python, you can choose various user interface tools available in Python. Say for an example, the tkinter is the one of the tools which are available for the UI designing. So similarly, we can install any different open source libraries for designing and user interface in Python. With this actually kind of adds flexibility, but not for a beginning level users. LabVIEW kind of development environment adds more flexibility because there is no need for you additional installations and all. So regarding hardware connectivity, LabVIEW basically comes up with all the device drivers and all the basic device requirement configurations and all. So for NI national instruments based devices and a third party based devices, you can use some LabVIEW based device drivers which basically works for you. But let's say for a Python, you actually have to support look on more support, and the hardware based stuff's actually kind of still not developed that much in the Python community. So actually, since the growing nature of Python and also interesting tools and applications with Python, LabVIEW found some more useful extensions for Python, which basically adds more functions and more meaning to Python and an application environment. So using some LabVIEW based DLLs and some other stuff which we're going to discuss in today's presentation, we can basically able to make sure the hardware kind of interaction in the Python environment. So typically, like if you want to perform some data analysis, you will be having so many libraries which are present in LabVIEW's built-in toolkits. So you can also install some external libraries. So this is something most of the times enough this the LabVIEW's built-in toolkits would more be sufficient to perform the different analysis. So in other ways, like in Python, you can basically install several libraries for different applications like NumPy, Pandas, and several other libraries. If you want to perform machine learning or deep learning, you will be going to have a various options to choose, and you can simply use some running command to install those libraries, and you can use the have the flexibility of the libraries in your code. But the point is like some Python codes won't have the required documentation, which actually makes the developer to run into several iterations before developing a proper code. But in the other ways, like if you have the LabVIEW codes, basically the built-in tools will come up with a various the better version of documentation with the help of the context help and the different defined and describe help functions. You can able to understand the usability of function in a clear manner, which will kind of able to make your development time to be more constrained. So this is some options and comparisons. And finally, the application deployment. Yeah, so using some PyInstaller's tools or some other tools, you can do the application deployment in Python, whereas you can do the deployment in LabVIEW with the executable. So let me some discuss about some general conventional use cases. So these are not only the use cases available for Python LabVIEW integration. I'm just pointing out some of the most kind of primarily used use cases. So one was actually recently discussed with by Durai Silvaraj. He was using the command line execution with the LabVIEW. That is one of the primary usage which can be established with for the LabVIEW Python integration. So the other things in after LabVIEW 2018, you might have completely know about this Python node. So Python node coming after LabVIEW 2018 is something different feature which actually makes sense. That community of LabVIEW is kind of extending the development and support towards the growing dev technology. So using the Python node, you can able to call your functions which are defined in the Python code. So the example was discussed by the Raj. So what I'm going to discuss on today's presentation would be like based on the real-time data acquisition on Python with LabVIEW based constructs. So basically what I'm going to do is I'm going to use the NI device. So basically I'm going to use a rack device and making the measurement. So that measurement will be now carried out from Python, not from LabVIEW. So I'm going to show that. So the other advanced ways are also being happening in the help of Python. This is kind of a LabVIEW based DLLs development. You have to develop your application in LabVIEW. Once you develop your application and functionality, you can create a shared library DLLs. Once you create a DLL, so this Windows kind of Windows based DLL developments can be included in the Python environment using the C types. So this part I am unable to extend on today's presentation. I would love to do. I would hope if anyone was interested on if going to support, I'm present on this. I would love to have a look on it. So let me start go with the today's demo. So what I'm going to do is like I'm going to perform a data acquisition, so which basically performed on Python. So in order to do that, I'm going to have a NI DataMex library. So for what I'm going to do, these are the prerequisites. I'm going to list out the prerequisites for doing this kind of thing. So what you have to do is you need to have a Python in your system. So that's the first requirement. Then you have to have your common NI DataMex and runtime engines in your system. So which basically install from the NI package manager. So it's a common use case, no? So in LabVIEW, if you want to use DataMex, you need to have the DataMex driver. So that same thing you have to install. So once you do, once you are already done with this thing, you can ignore these steps. So once you're ready with the first two steps, you can proceed with Python. So in your Python environment, you can do it in a command prompt or a Python command argument itself, or else like you can do it on some integral development environments like Spider or Jupyter Notebook or something like that, whatever it is. So where you have to use the pip command to install the NI DataMex library. So in order to install that, you have to you can use any of the available commands here. You can use pip install or easy install. So both will work for you. So once you perform these commands, you will be able to have flexibility of any DataMex tools in LabVIEW. So let me go through with the code. So for performing the data acquisition, what I have made is I actually created a simulated a DAC device from a NI Max. So what I did was I have this my NI Max here. So I have created a new device from devices and interfaces. So my new created device was NA USB 6002 device 3. This is my new device. So 6002, the USB is commonly used for many OEM based developments. So which compromises of various analog inputs and outputs and digital inputs and outputs and counter based inputs and outputs. So what I'm going to do is I'm actually going to do some analog input measurement from the Python. So this is about the simulated device. So once I successfully created the simulated device, I need to make sure and note down the device physical channel names and the channel IDs. So once I know about that, I can able to use the Python code to simply read the value. So this below code will able to read your value from an analog input channel 0. So what I have done is I have imported the NI DataMex after the installation of NI DataMex library. So once I done with that, I am actually creating a task. It is similar to you performing your LabVIEW development. No? So where you basically create a task, which is a task for performing one set particular data collection, right? It could be an analog input acquisition or it could be an analog output generation. So it differs based on the type of your measurement. So I'm going to create a common task. I'm going to use the task object to call my NI channels, AI channels, and I'm going to add my AI0, which is a channel I name. So if I have to represent with the physical channel address, we have to mention the device number, so which can be found here. So let's say this is the name of the device. So what you have to do is, if you went to test panels, can able to find the channel name. No? So this is the physical channel name. You have to copy that. So once you copied that, you have to apply the name of the physical channel. So once you're done with that, you use the same channel object to with a start. So this will actually starts the process of data acquisition. So once you started, if you want to get the data, you need to read the data. So that was done here. So this read function will return the data into the value function. So I'm going to read the value. So if I actually have this, what actually makes is I'm going to copy this into open. I have a Jupyter, I have a Spider notebook opened in my system. So I have this. So what I'm going to do is I'm just going to save as a demo.py and I'm going to run this. So mm, okay.
Need to make your intents proper.
Sorry, what?
There is space before task. You need to remove all those empty
Oh,
spaces in the start of the line.
yeah, yeah, understood. Mm, okay, understood. Sorry. So thanks for the support. Yeah,
No
so
problem.
you can able to see the value was created, no? So this will basically does the basic data acquisition. So in a typical common world, you should not be able to do the simple one read operation where your sampling things are coming to picture. So where I am going to use need to mention my sampling rate, and I need to acquire on a fixed time interval. So where I couldn't able to simply like randomly call a function and read the data without mentioning the timing. So which basically adds the constraint here. So what I'm going to do is I'm going to add the time library from the Python, which can able to make a call for this code. So I'm going to add some simple, commonly used fundamental programming constructs to build this application to be more sensible. So what I'm going to do is, so yeah, so here I have added the in time library. So to perform some data appending operations and number related numbering operations, I'm added the NumPy library, and I have created the matplotlib, imported the matplotlib library to plot the data appended from this. So what I'm going to do is, so let me explain about these variables before. So what I have previously done was I have created the task and performed a data acquisition only. But here what I'm going to do is I'm going to acquire certain amount of iterations, and I need to acquire on certain amount on some proper constant time intervals. Let me do with this. So I'm fixing my sampling rate as 1 samples per second. So what I'm going to do is I'm going to acquire at least one sample on each second. I'm going to sleep other on the other time duration. So what I'm with that, I made the for loop to run for 10 iterations. So which basically making the loop to run for 10 iterations. During each iteration, I am going to append the data into the data array. That is why this data array was created. So this is actually made for the data acquisition loop. So once that for loop and these things were completed, I am going to plot the data acquired on the data, appended on the data. So this is the plot function obtained extended from the matplotlib library. So once I run this, what happens is, okay, 1 minute actually, I have to restart. So I'm going to run this. Yeah, it's working. So I'm acquiring values at every 1 second. So I'm going to acquire for 10 samples. So once the end of 10 samples, the plot, okay, something happened in this. Sorry about some issue. So we can able to plot this plot as using this plot library. If you just went through this, I have to enter this code. Fine. Otherwise, if any other issues or questions related to whatever I have discussed, yeah, I am happy to answer. By the way, engineer state. So these are some other libraries available for the Python integrations. If you want, have a look on. Yeah, I am.
Thank you, Arshad, for sharing this information. Yeah, yes, Vignesh, please proceed.
I have a doubt, Arshad. So,
Yeah,
will all the error messages from basically the error out, right? So,
yeah.
the hardware error, all those will be displayed in Python. Is it working properly or?
So what's your question, man?
No. What my question is, so when I use LabVIEW, so if hardware is reserved or
Yeah,
all those hardware errors or the LabVIEW will throw some errors, right, when we are
yeah, yeah,
running,
yeah, yeah, yeah.
whether the sampling rate is wrong or
Yeah, 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 exactly.
all those will be displayed in Python
Uh,
itself, or is it
in
handled properly?
Yeah, yeah, it actually whatever we used to have in the academics library or in the LabVIEW environment, it's
Mhm.
actually almost commonly replicated in the Python environment here. So even if in today whatever I wanted to present, first time I was actually run into error for a device result. So because actually what happened is one before that I performed one example where I haven't closed my task. So
Mhm.
if you look on the code, so basically like whatever I performed on that, actually I missed the code. So this is the code I did there where actually I haven't made any task closing operation. So which basically made the device reserved on that code itself. It's not even able to accessible by the other application. So that is what error was happened, and if you see in the console window you can able to see the error for that issue. So actually I have restarted the Python, that's why it missed. So you can able to have it have the errors and those commands in the Python itself, that it won't need the similarly whatever you are going to have it on the LabVIEW environment with the error cluster. So all those errors will be mentioned in the Python itself, which basically adds your more flexibility in the development side. But I'm not sure about the complete support or the use cases on the uh, troubleshooting aspects of the hardwares. But maybe right now whatever we have is a good starting point. On the time go in the time with the time development is going on, support things will come into picture. We'll basically able to establish more proper functionable things in the Python environment itself.
Yeah, thank you.
Yeah.